Hello everyone, once again welcome to Physics Infinity channel. I am going to take on a very interesting problem of a disk that is rolling and then it is making a collision with a vertical smooth wall, and then we are going to find its velocity once again after collision when it begins to pure roll. So let me elaborate the problem. There is a solid disk, uniform disk of mass m and capital R, and it is rolling without sliding with the velocity v0 and angular velocity omega naught towards a smooth vertical wall. The floor is rough, surface is rough and has coefficient of friction mu. The surface is at rest. The disk after collision, let's say it's given the coefficient of restitution is E. So as it slides, as it strikes, then just after collision, its velocity will become V, that is EV0, and this is to the right, and the angular velocity omega naught will remain unchanged. Why? Because the vertical wall given is smooth. So there will be no tangential impulse from the smooth surface here. So after collision, just after collision, I am taking that time to be t equal to 0. So just after the collision, at the instant t equal to 0, which I am taking, now look at the free body diagram once again, weight down, normal contact force up, and the velocity at the point of contact will be EV0 plus omega naught r. So it is a case of forward slip. If it is a case of forward slip, then obviously there is a kinetic friction Fk, point P sliding with respect to surface. So kinetic friction Fk will act to the left. Fk will play its role as usual. It is going to bring the disk into pure roll again. How? I have explained that in my previous video lecture as well, but again I explain that Fk will first of all retard this velocity, translational velocity, till it becomes v dash after time t when it begins to pure roll. And during this time, Fk creates a clockwise torque about an axis perpendicular to the disk passing through C, and this will create an angular acceleration, and at the instant t, the angular velocity omega naught will become, let us say, becomes omega dash clockwise, because this is creating a clockwise torque. Fk is creating a clockwise torque. So finally, at the pure roll, at the instant it begins to pure roll, then this is omega dash, and its translational velocity becomes v dash. So Fk as usual has decreased the translational velocity and increased the angular velocity clockwise in such a manner that v dash minus omega dash r. So if I look at the velocity at P, it has two components due to translational, v dash forward, and due to rotation tangential velocity backward, that is omega dash r. And if omega dash is v dash by r, then Vp will become 0. Vp becomes 0, Vs is 0 given already, surface is at rest. So this is the instant when pure rolling begins. Now I have to find v dash in terms of v0. Fine, I have several methods that I have taught you in my earlier video. We can have conservation of angular momentum about an axis through P perpendicular to the disk, or dynamical method, or work energy method. Of course, the quickest and the best method that I feel for your competitive exams, you will take the principle of conservation of angular momentum about an axis through P perpendicular to the plane of the disk. But then do remember that the angular momentum will have two parts, the orbital part where due to translational motion, and the spin part due to rotation. Rolling is a combination of translation and rotation. So there we are, I apply. And of course the clockwise, anti-clockwise, the vector, because these are angular momentum is an axial vector, so that will take care. If it is clockwise, then it is minus k cap, and if it is anti-clockwise, it will be k cap. So there you are. So Angular momentum at O equal to angular momentum at the instant t when it begins to pure roll. So orbital angular momentum mvr minus k cap plus spin angular momentum I omega naught, moment of inertia times angular velocity. So mr square by 2 omega naught, and this is of course k cap. This is k cap. This is k cap. Now at the instant t, the orbital, so I can say this is orbital and this is spin. This is spin. So same here, this is orbital, and this is spin. This is spin. So there you are. I just put the orbital, that is mv dash r minus k cap clockwise, and mr square by 2 omega minus k cap. So once again, both these are clockwise angular momentum. So coming out to be minus k cap. Well, I don't have to do anything now. Well, the simple mathematical steps. Well, r would cancel, m would cancel, r would cancel everywhere, and I just solve this out, and I obtain v dash equal to 2e minus 1 by 3 into v naught. 2e minus 1 by 3 into v naught is the answer to the velocity. I hope you have liked the video, you have understood this problem. If you have done that, if you have understood this, so this is a beautiful explanation that you have got now, where a disk is rolling, it is colliding. So you are using the concepts of rolling, you are using the concepts of collision, and then you are using the conservation of angular momentum. So many principles that you have learned through this problem. I hope you have enjoyed the video, and if so, please don't forget to subscribe my channel, like the video. Thank you very much for listening to me and watching my video.
If you love the video and want me to make more useful videos for you, subscribe my channel and hit the bell icon to stay updated.